Welcome to the first part of Unit 10. In Unit 10, we are switching gears and going to look at motion from a different perspective. And that different perspective is from the concept of work and energy. Now, to begin with, let's go over the units for work and energy. So work and energy, both, I guess I didn't really need to write that, have units of joules, where by definition 1 joule is 1 kilogram meter squared per second squared. Okay. Now you may look at that and go, well, that's very similar to what we had for force. So remember, force by definition was 1 kilogram meter per second squared. So another legitimate unit for work and energy is 1 Newton times meter. Okay, so now we got units under our belt here. One other comment about work and energy is that they are scalars. Okay. Work and energy do not have directions associated with them. In particular, work will have a plus sign or a positive sign and a negative sign associated with it. But that is indicating the direction of energy in and out of the system. If it's positive, energy is coming in. If it's negative, energy is going out. But it is not a direction as like north, south, east, west, or up or down like we've had for force and velocity and acceleration. Okay, so what is work? Well, work isn't the everyday you think of. It is such a different definition in physics than it is in everyday life that I know faculty members at other institutions that if I could be half as good a teacher as they are, everyone would call me fantastic. So they're very aspirational for me. And these very, very good teachers don't use the word work when they teach this unit to separate it from the everyday use. So what word do they use? They use Werk, which is really, really fun to say with the kind of Germany accent and everything. Just to get it out of your mind. So when you think of work in everyday, you think about, well, that thing that you go to after you're done with your classes. Maybe it's from 9 to 5, depending on your what it is. But it's something that you do outside of living everything else in your life. It enables everything else in your life because it's the thing that provides you income. Okay, that's not work in the physics sense. So what is work in the physics sense? Okay, so work in the physics sense is something that is done by a force acting on an object as the object moves in a direction parallel to that force. So for example, if I have a block moving across the floor this way, and the reason it's moving across the floor that way is because there's a string attached and somebody's pulling it, this tension force would do work in the physics sense because it is in the direction of the velocity. So if I draw the free body diagram here really quick of this block, friction surface on block, normal surface on block. Oh, we'll do rope on block and earth on block. So tension will do work, and it would be positive number. The normal force and the weight force would not do work because they are not in the direction parallel to the force. The friction force will do work because it is anti-parallel to the velocity. Okay. By definition, work is given by W equals FD cosine theta. So now you're looking at this W and you're looking at that W and going, oh, too many W's. Okay, so yes, you could definitely have a situation where the weight force is doing work and end up with W equals W, which could get very confusing. So I'm going to encourage you to figure out some way to distinguish one from the other. My weights always have subscripts, so I recognize them as forces. My works do not. So that's what works. That's what works for me. Haha. Maybe you write one of your doubles with bigger wings or something to make them distinctive. Come up with something. It'll be okay. Okay. If we look at the tension and velocity are parallel. So in this case, theta would be 0 degrees. Cosine of theta is 1, or cosine of 0 is 1 is what I meant to say. For the normal and the weight, we would have a 90-degree angle, and cosine of 90 is 0. So again, that supports these two forces do not do any work on this object moving in this direction. Friction, the angle would be 180 degrees because it points opposite the velocity. Cosine of 180 is going to be negative, and now you can see what I alluded to earlier, where sometimes work will be positive, sometimes work will be negative. Here we have one force doing a positive amount of work and another doing a negative amount of work. Okay. Well, we've already done this. So a block slides across the floor to a stop. Oh, well, in this case, it's stopping. How much work does each force that acts on it do? So here we have our block. It is at this moment, say, moving this way, and at some time later, I guess I need to extend my floor, here V equals 0. Okay. Well, in this case, we only have 3 forces. The normal force, the weight force, and friction. I got rid of my string. As we've already discussed, the work from this one is 0 joules, and the work from this one is 0 joules. If you want to think about it as the angle is 90 degrees and therefore the cosine goes to 0, great. If you want to think about it in terms of velocity is to the right, normal force or weight force are up and down, and that's not parallel to the velocity, golden. The friction force is going to do work. And the question is, how much work does it do? Well, between this location and this location, let's let that be, say, a distance of 3 meters. In this case, the work will equal the friction force, whatever, oh, I don't know where that M came from. Let's try B again. Whatever this one happens to be, we could go back to what we learned a couple units ago and write it in terms of the normal force and all of those things. We would then have to multiply by 3 meters because that would be our distance. And the cosine would be cosine of 180 degrees again because velocity points this way, whereas friction is opposite, and that is 180 degree angle. In the next unit, we are going to do some examples, actually working with numbers on the amount of work that is done in various situations.